Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos, Ukobela Wemets. And without any further ado, let's look at these questions that we have here. Ra- Okay, so we have question 5 on work, energy, and power. It says an ice skater of mass 53 kg moves on a frictionless surface AB with a velocity of 6 meters per second and then slides up a rough inclined surface BC until coming to a stop at point C, 1.5 meter above the horizontal. The angle between the incline and the horizontal is theta. So we are not given the value of the angle there. 5.1 says state the work energy theorem in words. So easy peasy, 2 marks there. So we say work energy theorem states that the network done on an object is equal to the object's change in kinetic energy. Right. So if you happen to forget this definition, just remember it from W net is equal to change in EK. So the network done on an object is equal to the object's change in kinetic energy. And then we have 5.2. It says, draw a labeled free body diagram showing all the forces acting on the skater at point C. Right. So at point C, we know that we will have our normal force perpendicular to the surface like that, and then straight in line here we have our gravitational force, and then since the ice skater will be moving up, that means frictional force will be acting down the incline there. And just like that, we have our free body diagram. So this is our normal force, this is our gravitational force, and this is our kinetic frictional force. Now, if you wish to resolve your components, then this is how you will be expected to draw. So here, you have this, and then you have your normal force perpendicular to the surface. You have your FG perpendicular, straight in line with the FN. And then sliding down the incline will be your FG parallel, and also the kinetic frictional force. So you need to make this circle bigger, or this dot bigger. And then there you go. So indicate FG perpendicular, FG parallel, FK, and then the normal force. Now you know if you resolve, they will mark this as 1 because these are components of FG, and then you have your FK, have your FN, right? So again, I prefer this one because with this you can see all the forces that are acting horizontally and all the forces that are acting vertical. But then always remember to then erase this incline here. They don't want to see that incline there. So you need to then erase that incline. And then now you'll be left with the free body diagram only, right? Okay, so for 3 marks, that's all you were supposed to do. Then now let's go to 5.3. It says explain the term non-conservative force, right? Explain the term non-conservative force. So what is a non-conservative force? We say this is a force for which the work done is dependent on the part taken. On the path taken. right? So a force for which the work done is dependent on the part taken is known as a non-conservative force. Now, examples of non-conservative forces, we know that can be your applied force, that can be your tension force, and also it can be your frictional force. So these are the examples of non-conservative forces that we have. And anything that does not fall between those three is not a non-conservative force. Then 5.3 says calculate the angle theta of the slope if the skater experiences a frictional force of 20 Newton while skating up the slope. Now, we just explained the term non-conservative force. I said the examiner constantly throws hints in there as to tell you which formula to pick. So with this one, we know that we have our incline here, and then we do have our height. So remember, I said when there's keywords like this is a rough surface, and then you can see that you have non-conservative forces like a frictional force, and then you also have height. All of these three here can act as a guide to tell you that the formula that you need to apply is the formula for work done by non-conservative forces. And then another confirmation again is the fact that you just explained the term non-conservative force. So we have WNC is equals to change in EP plus change in EK. Right. Now, our only non-conservative force here is the FK. So we'll just break this down to work done by FK. So which we can just say this is FK delta X and then cos theta. And then break this one down. It's mg, height finally minus height initially, plus half, and then m vf squared minus vi squared. Right. Now, what is our fk? That's 20. And then we are looking for delta x first. So note this, in order for us to be able to calculate the angle here, theta, we are going to use our trig ratios, specifically sine theta, which means that we'll have to take the height over the delta x. Remember, for sine, according to SOHCAHTOA, it's opposite over hypotenuse. So that's h over delta x. That's how we are going to get the theta here. But then looking at this, we do not have delta x. We do not have the displacement. So that means the first thing that we'd have to figure out is delta x before we can get to calculating the angle theta there. So if we can first get the displacement, then we can then use the displacement to get the angle. So it's always the trend with that question. Whenever you see a question whereby you are required to calculate theta, always put it in the back of your mind that the first thing that you need to calculate is the displacement. Then from getting the displacement, you can then find the angle of the incline. Right, so that's 20 delta x and then cos. The theta here is not the theta that we are looking for. Remember, this is the angle of the slope, and the theta here represents the direction between the force and the displacement. So since Fk is going opposite to the displacement of the skater, it's supposed to be 180 degrees. We always know with Fk that theta is 180 degrees because it always opposes the motion. Then our mass is 53. We have 9.8 here. The height finally, so at point C, the height will be 1.5, and then minus 0, then plus half. Our mass again 53. And then the final velocity, remember, it comes to a stop at point C. So it's supposed to be 0 square. And then initial velocity, are we told there? When we read there, it says with a velocity of 6 meters per second. So an ice skater of mass 53 kg moves on a frictionless surface A to B with a velocity of 6 meters per second. So at this point, it's 6 meters per second. So we're going to have 6 and then square that. Now, we simply need the aid of our calculator here. When we punch this, this is going to give us negative 20 delta x. And then when we punch all of that into our calculator, we get a negative 174.9. Right. And then we can divide both sides by negative 20. Negative 20. Then our delta x is supposed to be 8.745 meters. But then remember, this is not what the question requires. We are supposed to calculate the angle of the slope. So this is when now we apply our trig ratios. Sine theta is equals to h over delta x, where our height is 1.5, and now our delta x is 8.745, right? So this is going to be theta is equals to sine arc, and then 1.5 over 8.745. Then you simply just punch all of this into your calculator. Then your theta will be equals to 9.88 degrees rounded off to 2 decimal places. And that's how you were supposed to tackle that question for 6 marks. So always put it in the back of your mind. I said whenever a question is about 5 marks and then above, it always tells you that there are 2 unknowns. So before you get to the one that you want to calculate, there is the first thing that you need to calculate. There's the first value that you need to find there, or a variable that you need to get a value of, and then from there on you can calculate the one that is required by the question. So this is basically what we did with that question there. First get our delta x, and then from delta x we can get the theta. Right, so with all that being said, guys, we've came to the end of the question. That's how you were supposed to tackle that for a total of 13 marks. And then if you enjoyed the lesson, please press the thumbs up button. And then most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.